Alright, so now we are going to go to infinity and beyond. We're going to talk about infinite limits. It's thrilling stuff. Buzz Lightyear has done this all before, so it's very doable, guys. But basically, what we have going on here is infinite limits is just when the function is going up and up and up forever, or down and down and down forever. And so this is an example of that. You can see right here where x equals 3, we have this situation where the graph starts to go down and down and down forever. And then if coming from the right, it's going up and up and up forever. It's basically anytime you have a non-zero number, so it's just like any number besides 0, divided by 0 indicates the presence of vertical asymptote. So here, on this one, if we did the limit as x approaches 3 of this thing, well, what would that be? Let's just kind of like think about that. The limit as x approaches 3 of f of x. Well, we can't just plug it in, because if we were to plug it in, what would we get? We would get, because f of 3 equals 2 times 3 plus 1, 3 minus 3. Well, we would end up with 6 minus 1, which is 5 over 0. Okay, so we can't evaluate the limit here this way, but what we do know now is that anytime we have a number over 0, we have some vertical asymptote at that point. Okay, that's what they're trying to tell us. So this is a vertical asymptote right here. That means it's going either down to infinity or up to infinity. Alright, so let's play with a couple example problems. Here's the first one. It says use the graph to see what is occurring at x equals 2. Well, we have the graph here. We can see that it has a vertical asymptote. So let's just see. What is the limit as x approaches 2 from the left? Well, as we approach from the left, we can see that's going down and down and down to negative infinity. So we could say that this is negative infinity. To prove that, right, we could find out what is f of 2 real quick. And we'd see that we get 3 over 2 minus 2. That's 3 over 0, so that tells us we have a vertical asymptote. So that's how I know this is going down to negative infinity. In the same way, I know that this side from the right, as I approach from the right, I'm going up and up and up to positive infinity. So what is the limit? Well, since these are two different values, and infinity is not really a value, but there are obviously two different things, we could just say that the limit does not exist. But we do know that one's going to negative infinity and one's going to positive infinity. Alright, let's go to the next problem. Okay, very similar problem. I encourage you to just kind of work this out on your own. It tells you what it's looking for right here. It says determine the limit of each function as x approaches 1 from the left and from the right. So we could just kind of write this as the limit as x approaches 1 of f of x. And let's do from the left. And then we could also say we want to know what is the limit as x approaches 1 from the right of f of x. I'd encourage you to just kind of try this on your own first, see if you can come up with it, and then check back to see if you have the right answer. Okay, so hopefully you saw that this thing from the left at 1 is just going down to negative infinity. So this should just equal negative infinity. And from the right, it's going up and up and up to positive infinity. That's really all there is to these questions. I'm not trying to trick you or anything here. But let's give you a little bit different one on the next page. Okay. It says determine the limit of each function as x approaches 1 from the left and the right. So same thing here. We're going to do the limit as x approaches 1 from the left of f of x, and the limit as x approaches 1 from the right of f of x. Okay, well, once again, I could just substitute in just to verify what is f of 1. I didn't do it in the last one, but you don't really have to. I'm just kind of showing you why we know that it's going to go to infinity. Well, 1 minus 1 is 0, so I get 1 over 0 squared. 0 squared, obviously, just 1 over 0. So we have an infinite limit here, or vertical asymptote. So what is it from the left? As we come from the left, we can see it's going up and up and up. So this is positive infinity. You don't really need the positive symbol there, but I'm just putting it there to demonstrate that it is positive. What is it from the right? It is going up and up and up as well. So this is also going to positive infinity. So that means that on this one, we actually do know the limit, the general limit, as x approaches 1 of f of x, it equals infinity. Pretty cool. We know that that thing equals, the limit is infinity at x equals 1. Pretty neat. Alright, see you guys in the next video.